Lesson 9 is on prime numbers. And what a prime number is it's a number that is only divisible by itself and 1. And the book explained it as if you can only make arrangements for that number if you imagine them as tiles, and the only way that you can arrange them is 1 by that number. Instead of, like, for instance, 6, you can have it be arranged 1 tile 6 in a row, or 2 tiles 3 in a row. That's not a prime number. That's called a composite number. So, number 1 says 3,690 people finished the half marathon. If 2/3 of the finishers walked a portion of the course, how many finishers walked during the race? So we have 2,690 people, and then of 2,000, or 2/3 of that, so that times 2/3. When I multiply by a fraction, I multiply by the numerator. So 2,690 times 2, and divide by the denominator. So I have 2,690 times 2 is 5,380, and then divide that by 3 is about 1,793. So when we have to round something in math, instead of a straight equal sign, we do a squiggly one, which means approximately. And 1783. Just to double check, 2,690 times 2 divided by 3. Yep, 1793, sorry. A doorway that is 2 meters high is how many centimeters high? Well, the conversion is 100 centimeters equals 1 meter. So the two fractions we can have are 100 centimeters over 1 meter, or 1 meter over 100 centimeters. So then we take the information they give us, put it over 1, 2 meters over 1. Meters is on top in this one, so it has to be on the bottom in the second one, which tells us to use that fraction. Meters will cancel then. And since 2 and 100 are both on top, they get multiplied. And we end up with 200 centimeters. Driving at 80 kilometers per hour, how far will Curtis drive in 2 hours, 3 hours, and 4 hours? So, we have 80 kilometers per hour. Kilometers per 1 hour. Hours are on the top, so then I would multiply here. 80 times 2 would give me 160 kilometers, since hours will cancel. And then I would do the same thing, but I would replace 2 with 3 hours. And then I'd have 80 times 3. 8 times 3 is 24. So 240 kilometers. And then 4 hours. Replace the 3 with a 4. And then 80 times 4 is 320 kilometers. So 4 hours, 2 hours, and 3 hours. Identify the plot, write an equation, and solve the problem. The railroad workers laid 150 miles of track in the first month. At the end of the 2 months, the total was up to 320 miles. So the plot looks like we laid some track, and then in the second month we laid some more, and we had a total. So this is a combining plot. So the equation would look like sum, which is the 150 from the first month, plus more, whatever they laid in the second month, equals the total of 320 miles. So to figure out what m is, we have to think what added on to 150 would give us 320, and it would be 170. You could also do 320 minus 150, that gives you 170. So how many miles did they lay in the second month? 170 miles. The workers laid an average of how many miles of track each month. So for this one, we take the total number of miles they laid, which is 320 miles, divided by the number of months they did it, 2 months. And then 320 miles divided by 2 months is equal to 160 miles per month. And you can see these units are right in our original equation. We have miles over months. Number 5, a traffic counter recorded the number of vehicles heading north through an intersection for a 7-day period. The following counts were recorded for the 7 days: 86, 182, 205, 214, 208, 190, and 126. What was the median number of vehicles counted? So to figure out median, we put the numbers in order from smallest to biggest. So 86, and then 126, and then 182, and then 190, 205, 208, and 214. So to find the median now, we take 1 off of each end, so 86 and 214, 126 and 208, 182 and 205, and our median is 190. What was the mean number of vehicles counted? To find the mean, we add up all the numbers and divide by how many there are. So we are going to take 86 plus 126 plus 182 plus 190 plus 205 plus 208 plus 214. And that equals we have 86 plus 126 plus 182 plus 190 plus 205 plus 208 plus 214 equals 1,211. And then there are 1, 2, 3, 4, 5, 6, 7 numbers. They counted for 7 days. So we divide that by 7. So 1211 divided by 7 gives us 173 for a mean. And that's reasonable. It's at least between our largest and smallest number. If it wasn't, we'd know we did something wrong. Are most of the counts closer to the median or the mean? Well, the median was 190 and the mean was 170. Most of the numbers are around 180 to 200, so it looks like most of them are closer to the median. We got 1, 2, 3 that are around 200, and then 190 is close to the median, obviously, since it is. A mile is 5,280 feet. How many yards is a mile? Well, we know that there are 3 feet in 1 yard. So we have 5,280 feet over 1. Feet needs to go in the bottom of the next fraction. So that'll put 3 feet there, 1 yard on top. Feet get canceled out. And since 3 is on the bottom, we take 5,280 and divide it by 3. So 3 goes into 5 once. 1 times 3 is 3. 5 minus 3 is 2. Bring down the 2. 3 goes into 22 7 times. 7 times 3 is 21. 22 minus 21 is 1. Bring down the 8. 3 goes into 18 6 times. 6 times 3 is 18. 18 minus 18 is 0. Bring down the 0. 3 goes into 0 0 times. So 1,760 yards. List the first 8 prime numbers. Well, in the practice we listed the first 10, so if we look back at that, we have 2, 3, 5, 7. You'd think 9, but 9 can be broken down into 3 and 3, so that's a composite number. 11, 13, and then 17. 1, 2, 3, 4, 5, 6, 7. One more. 23. Oops, 19. And all of those numbers are only divisible by themselves and 1. So the only way to get 19 is either 1 times 9 or not 1 times 19 or 19 times 1. Simplify. 100 centimeters minus 68. Well, if I take 68 and I add on 2, that gets me to 72. And from 70 to 100, that's 30. So it must be 32. Number 9, that big number. So I have 2970.98 minus 1429.59. Can't subtract 9 from 8, so I have to borrow. That becomes 18. 18 minus 9 is 9. 8 minus 5 is 3. Keep the decimal point where it is. Can't do 0 minus 9, so I gotta borrow. That becomes 10. 10 minus 9 is 1. 6 minus 2 is 4. 9 minus 4 is 5. 2 minus 1 is 1. So this is 1,541 and 39 cents. 5,280 divided by 30. Well, we did 5,280 divided by 3 in problem number 6. So divided by 30, you just take a 0 off of it, so it would be 176. And the last one, 123.45 divided by 3. Running out of room here, so I'll come down here. 123.45 divided by 3. So I'll put my decimal point in. 3 goes into 12 4 times. 4 times 3 is 12. 12 minus 12 is 0. Bring the 3 down. 3 goes into 3 1 time. 1 times 3 is 3. 3 minus 3 is 0. Bring the 4 down. 3 goes into 4 1 time. 1 times 3 is 3. 4 minus 3 is 1. Bring the 5 down. 3 goes into 15 5 times. So it's $41.15. Find the perimeter and the area of the rectangle. So, perimeter, I'm going to add 44 plus 44, which is 88. And then the two widths, 32 and 32, is 64. And then 88 plus 64. 8 plus 4 is 12. 8 plus 6 is 14, plus 1 is 15. So 152 is the perimeter. And that's in inches, since that's what the units are on the length and width. And then to find area, I multiply those two numbers. So area equals 44 times 32. Is 1,408. And then that's in inches squared, since my original units are inches and area is the units squared. In number 13, they asked us to find the perimeter of the triangle. Just like the perimeter of a rectangle is, you add up all the sides. You do the same for a triangle. So 12 plus 15 is 27, plus 19 is 37, and then 9 more would be 46. Find the perimeter and area of this figure. So this is like an example that we did in class. To find the perimeter, we need to figure out what are the lengths of the two sides that don't have numbers. So if I was to trace this across here, I know that this distance is 3, because it's across from 3 inches here. And if this whole side right here is 6, that means that this distance must also be 3, which would make this distance 3. Then, if I do the same thing, but the other direction, and trace it back this way, that tells me that this distance is 4, which means if this whole side is 9, this distance is 5, which would make this distance 5. So to find the perimeter, all I do is add up all the sides. So 3 plus 5 is 8, plus 3 is 11, plus 9 is 20, plus 6 is 26, plus 4 is 30. So the perimeter is 30 inches. And that comes from 3 plus 5 plus 3 plus 9 plus 6 plus 4. To find the area, we need to cut it into two rectangles where we can find the area of each of them. So I can do it one of two ways. This is one way. This way I have a rectangle that's 4 by 6, and I have a rectangle on its side that's 5 by 3. So I find the separate areas of each of those. So this one would be 3 times 5, which is 15. This one would be 4 times 6, which is 24. And then you add those. So 15 plus 24 is 39. And the units are inches. So area's units are inches squared. Now, if you would have done it the other way, split the rectangle a different way, you should have gotten the same answer. So if I instead split the rectangle this way, then this rectangle right here would be 3 times 9 is 27 inches squared. This one right here would be 3 times 4, which is 12 inches squared. And then you would say your area is 12 plus 27, which is 39 inches squared. So either way you cut it, it still ends up being the right answer. So you don't have to worry about dividing it in an incorrect way. A rectangular room is 15 feet long and 12 feet wide. How many feet of baseboard are needed to reach around the room? Ignore door openings. So they're asking for the perimeter. So if I have a room that's 15 feet by 12 feet, then the perimeter is 15 plus 12 is 27, plus 15 is 42, plus 12 is 59. Let's check that. So 2 times 12 plus 2 times 15. 2 times 12 is 24. And 2 times 15 is 30. So 54. I miscounted. So 54 feet of baseboard would be needed. The perimeter of the room is 54 feet. How many 1-foot square tiles are needed to cover the floor? So now they're asking for the area. So if we were to cut this up into 12 slices and 15 slices, how many squares would you have? What's the area of the room? So 15 times 12. 15 times 10. If I break up 12 into 10 plus 2, then I have 15 times 10 plus 15 times 2. 15 times 10 is 150. And then 15 times 2 is 30, which is 180. And the units were feet, so units for area are feet squared. So how many 1-foot square tiles? You would need 180 tiles to cover 180 feet squared. For problems 16 through 19, find the value of the variable that makes the equation true and state the property illustrated. So we have 5 plus 4 equals 4 plus a. So a has to be 5, and that is the commutative property, which says order does not matter. And it doesn't matter for addition or multiplication. And then 17 is also going to be the commutative property. So B is going to be 18. And that's the commutative property, this time showing that order does not matter for commutative multiplication either. 20 times C equals 20. Well, the only way to get a number back when you multiply is to multiply it by 1, and that's the multiplicative identity. And then 21 times D equals 0. Well, If I multiply a number and I end up with 0, then that number must have been 0 itself. And that's by the multiplicative property of 0. It says that anytime you multiply something by 0, your answer will be 0. What is the absolute value of 9? That's asking you the question, how far away from 0 is 9? It's 9 away. So the absolute value of 9 is 9. Simplify and compare. The absolute value of 12 is 12 spaces away from 0. Absolute value of 11 is 11 spaces away from 0. So absolute value of negative 12 is greater than the absolute value of 11. If 13 and 5 are factors, what is the product? So factors means they're going to get multiplied. So 13 times 5, and that can be 5 times 10 is 50, plus 5 times 3 is 15, so 65. If 225 is the dividend, and 15 is the divisor, then what is the quotient? So 225 is the dividend, so it means 225 divided by 15 equals, well, if I write it this way, 15 goes into 22 once, 1 times 15 is 15, 22 minus 15 is 7, 75, bring the 5 down, 15 goes into 75 5 times, 5 times 5 is 25, whoops, so 5 times 15 is 75. So the quotient is the answer in a division problem, is 15. For problems 23 through 26, choose all the correct answers. 27 is a member of which set or sets of numbers? Well, 27 is a whole number. Whole numbers are counting numbers including 0. B, it's a counting number. I can count up to 27. That is a whole number starting with 1. And it's also an integer. Integer includes the whole numbers, counting numbers, and negative numbers. Number 24, 0. You do not count 0, so it's not a counting number. It is a whole number, and it's also an integer then, because integers include all the whole numbers. Negative 2 is a member of which set of numbers? So it's not a whole number, those are only positive. It's not a counting number, those are only positive. And then it's an integer. Those are the only ones up there that include a negative number. The number 5,280 is divisible by which of these? Since it ends in a 0, it's even. It's divisible by 2. If I add up 5, 2, 8, and 0, 5 plus 2 is 7, plus 8 is 15. 15 is divisible by 3, so 5,280 is divisible by 3. The last two digits make 80. 80 is divisible by 4, so it's divisible by 4. And it ends in a 0, so it's divisible by 5. So it's divisible by all of those. List all the prime numbers between 30 and 50. So we have 30 is divisible by 2, so that's not it. 31 is not divisible by 2, not divisible by 3, because 3 plus 1 is 4. It's not divisible by 4, it's not divisible by 5. So 31. Then 32 is divisible by 2. 33 is divisible by 3. 34 is divisible by 4. 35 is divisible by 5. 36 is divisible by 2. 37 is a prime number. 38 would be divisible by 2. 39 would be divisible by 3. 40 is divisible by 2. 41 is prime. 42 is divisible by 2. 43 is prime. 44 is divisible by 2. 45 is divisible by 5. 46 is divisible by 2. 47 is prime. 48 is divisible by 2. 49 is divisible by 7. And then 50 is divisible by 2. Use a factor tree to find the prime factors of 490. So we start with 490. So I could do 70 and 70. And then 70 would be 7 and 10. And then 10 would be 5 and 2. So the prime factorization is 752, 752. Use divisions by primes to find the prime factors of 48. And write the prime factorization of 48. Well, a prime number that goes into 48 is 3. So I would take 48 and divide that by 3, which would give me, let's see, 3, 30, so 10 and 18, so 16. And then I divide that by 2, which is a prime number, which gives me 8. And I divide that by 2, which is a prime number, gives me 4. And I divide that by 2, it gives me 2. And the last one, we have 4 times 23 times, or 40 times 23 times 50. So I want to rearrange it. I want to get the 40 and the 50 next to each other. So I'm going to do 40 and then times 50 times 23. I can do that by the commutative property, which says I can reorder them. And then I'm going to regroup them, 40 times 50 times 23, by the associative property. And then 40 times 50, well, 4 times 5 is 20. And then I have 2 zeros times 23. And then 2 times 23 gives me 46. And then the zeros at the end.